Okay, welcome to the last video that we're going to do for the 2D shapes and angles portion. And once you finish this, I think you'll be ready for some of the side projects. And then once you finish those, you can take the mastery test. So this is exciting. We're going to talk about one of my favorite topics in mathematics and just, I guess, in general, symmetry. So what I want you to do in your book is finish this sentence. Symmetry. It says symmetry is. I want you to finish this sentence. What do you think? What do you think symmetry is? If you're not sure, you maybe say something that is just a guess. That's fine. We all have some idea of symmetry. You've heard this name before, so write that down and then keep watching. Okay, you got some definition of symmetry. You can pause the video if you don't have enough time. And let's see what symmetry is to me. To me, symmetry is the following. Symmetry is the property of two sides being balanced. That's pretty simple, isn't it? Okay, let's take this love heart for example. Alright, if I draw a line down the middle of it, which I'm going to call the line of symmetry, or we're just going to abbreviate LOS, the line of symmetry, you realize that this side on here on the left, this side, okay, this is balanced with this side. They're the same. If I could somehow reach into the screen and fold it in half like that, that would have exactly the same shape. So symmetry is the property of two sides being balanced. And the last thing I'll say about this is the word property is kind of funny, because we've talked about property in the very first video. Take for example a square. Okay, a square has a few properties. Get out of here, love heart. Okay, a square has a few properties. We said before that all 2D shapes have angles. All 2D shapes have sides, and all 2D shapes have corners. Those are properties of a 2D shape. Properties. Okay, properties. But what you're learning now is that symmetry up here is also a property that 2D shapes may have. Not all of them do, but some may. Some may have them. A square is a great example of a shape that also has a property of symmetry. Let's take a look at a few more. Here's a star. At first glance, it seems like maybe a star wouldn't have any lines of symmetry, but if you take a straight line and put it down the middle, you realize, wait, I could fold this in half, and I could have the same shape on one side. It would be an irregular shape, but that's fine. Doesn't matter. You can make a symmetrical shape. How about one like this? Let's take a look. At first glance, this looks like it doesn't have any lines of symmetry. You think, well, hang on, I can't take this side and fold it over to here. That wouldn't work. But what if I turn it? Maybe I can turn it. There we go. What do you think? Symmetrical? No, it's not symmetrical. Of course not. Okay, I can't take this side and fold it over to here. No matter how I try to divide this up, no matter where I move, no matter where I move this line, I'm not going to be able to create a space that is symmetrical. So some lines do not have the property of being balanced. I'll say that again. Some lines do not have the property of being balanced. This is not a balanced shape, so to speak. Here's a good example of a shape that has a lot of lines of symmetry. Okay? Do you think you can find all the lines of symmetry on this shape? It's got more than one. And this is where symmetry gets tricky, because people think, oh, every shape must have one line of symmetry. Check it out. Love heart, one line of symmetry. My pointed star appears to have one line of symmetry. Mr. Pentagon over here has more than one line of symmetry. Write down how many lines of symmetry you think the pentagon has. Okay, keep that number down. We're going to talk about it in a second. I've got a few shapes here now, and I've divided them up with some lines of symmetry. I've got the triangle, the square, the pentagon, and the hexagon. So, I want you to draw these in your book, each one of these shapes, and see if you can divide them using a line like I have in as many ways as possible. Okay? So, you're going to draw these shapes. Give myself some more room to type. In your book, and try to find all the lines of symmetry for each shape. Good luck. Good luck. Man, I'm a pretty fast typer, aren't I? Okay. So pause the video, and when you're done, we'll do the last slide and see how you went. Whoa, look at that. What's going on here? Okay, well, what's happening is I have color-coded each new line of symmetry for each shape. So we can clearly see how many lines of symmetry are on each shape. Let's just look at the triangle. Okay, I'm going to put this over here so we don't get confused. Let's look at the triangle. Okay, if we split the triangle in half on the green line, we have one line of symmetry. So I'm going to put this down here like that. If we split the triangle on the corner here, you can see I could fold that to here. That's another line of symmetry. Okay, and if I split the triangle on from here to here, you can see how I have another line of symmetry. So all in all, the triangle has a total, this triangle anyways I should say, has a total of 3 lines of symmetry. 3 lines. Now I know it looks like more than 3 lines. It actually, it looks like 1, 2, 3, 4, 5, 6. It looks like 6 lines. But remember, like this line is the same line whether it's down here or up here. It's like whoosh, one line cutting through. So it's got 3 lines of symmetry. Cool? Capiche? Alright, let's try the next one. Square. Okay, things are getting quite complicated now. But let's just focus on the colors. We have a line of symmetry here if we fold the square in half that way. If we fold the square in half on a diagonal, on an angle, we have another line. If we do the opposite angle, we get the 3rd line. And then if we fold it in half, what do we call that, landscape, I guess? Well, I guess not landscape, it's a square. If we fold it in half on the other side, we get the 4th line of symmetry. So a square has 4 lines of symmetry. I know, now what I said before, you still got to remember, it looks like more. It looks like that's a line, and 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 that's... It looks like 8 lines. But remember, this line goes all the way through. So it only counts as 1. So the square has 4 lines of symmetry. I bet you can guess what's next for the pentagon. If you said that there are 5 lines of symmetry, you are correct. 5 lines. Let's take a look at each of them. Get out of here, 5. Okay. Well, we got your blue line, which cuts across this half. We've got your green line, which cuts across the main middle, I guess you could call it. The purple line might be the hardest for you to think about. I'll leave it there for a second. Let me get the orange line. Is kind of like if the pentagon was turned upside down. The red line. And now, can you see how the purple line, can you kind of tilt your head and see how it actually splits this pentagon directly in half? So we have 5 lines of symmetry. 5 lines of symmetry. Put these back somewhere. I did not do a good job of putting my things away. It looks a bit weird. This one is okay. There we go. 5 lines of symmetry. So lo and behold, we have the hexagon, and we do have a total of 6 lines of symmetry. Now I know I've said this 3 times already, but don't get confused. This is not how we count lines of symmetry, like what radiates from the center. No way. We count them as the whole line that divides the shape. And if you actually look here, there's only 6 lines dividing the shape, even though it looks like there's 12. So, what is the relationship that you've discovered between the number of angles on your shape and the number of lines of symmetry? Look at this. Triangle has 3 angles and 3 lines of symmetry. Square has 4 angles and 4 lines of symmetry. Pentagon 5 and 5. Hexagon 6 and 6. So there's a relationship between the angles on these regular shapes and the lines of symmetry. Isn't that beautiful? Well done, guys. One more thing I just want to show you before we finish this video. You know, lines of symmetry are everywhere. We see them in nature all the time. This is an incredible picture. Now, these I don't think are real colors. They've probably been enhanced. But if you were to draw a line of symmetry to divide this incredible bird, where would you do it? I think it's almost obvious, isn't it? You do it straight down the middle, right? You've got this line of symmetry that cuts the bird in half. Incredible. So lines of symmetry we find in nature all the time. Look at this plant. Where's the line or lines of symmetry on this plant? It's actually like nature is giving us a hand. You can see this line actually on the plant going right down the middle, just like that. Isn't that beautiful? It actually has 2, I think. I think you can go this way as well, right? Fold the plant in half the other way. And like you can see little ones down here, you know, off in the distance. Pretty incredible. So nature loves its lines of symmetry. one of my favorite examples, not my most favorite, but one of my favorites, is the incredible snowflake. Okay, the snowflake has lines of symmetry, and well, just check this out. You guys will think this is cool. Watch this. Okay, if I draw a line here, I can divide it in half. That's one line of symmetry. Change my color. And go 2 lines of symmetry. Okay. 3 lines of symmetry. Now, another line of symmetry that might not be so obvious is that I could actually cut it in half like this. 4 lines of symmetry. And can you see where the last one's going to go? 5 lines of symmetry. And if you were kind of looking at this for a while, you might realize that this shape of the snowflake is actually a pentagon. Oh, sorry, not a pentagon. An hexagon. Of course, there's one more line of symmetry. This one down here in the middle. That's funny. Okay, so the snowflake has got 6 lines of symmetry because it's actually a hexagon. It doesn't look like a hexagon. Like if I get rid of all this stuff, bye-bye. If I get rid of all this, you look at this and go, that's not a hexagon. And of course, it's not really a hexagon, but it's got the symmetry of a hexagon. It's got 6 lines of symmetry. Isn't that incredible? That just blows my mind. I really love these snowflakes. Okay, what else? How about something yummy? Can you find a line of symmetry on here? Now, sometimes, you got to give nature a bit of a break. Like, it might not be exact. It might be, like, a little wonky. But you got to be able to appreciate, the fact that you can cut this thing in half and have it be reflecting almost anywhere. Which reminds me, a perfect circle, like this, has infinite amounts of lines of symmetry. Isn't that wild? So, circles can be split in an infinite number of ways to be made symmetrical. Let's look at another example. Symmetry in nature. Where would you draw on the poor elephant's face to show symmetry? Yeah, just down the middle, right? Oops, that wasn't good. Undo. There we go. See? Lines of symmetry. Very, very cool. I think this is a beautiful image. I actually think that this was made to be perfectly symmetrical by a computer. I don't think this is like a real picture of an elephant, because there's a few clues here, which I've only just realized. Look, there's a hole in the ear here, and a hole in its ear here. Like, that's a crazy coincidence. And then there's one here, and one here. And even if you actually, once you start looking at this, I think this was done by a computer, because even like some of the designs around here are literally identical to what's over here. But that's okay. For our purposes, we can just understand that faces can be symmetrical. In fact, I have an actual face here. I like this picture. Where would you draw the line of symmetry on this boy? And we don't want to be rude. Sorry, man. We're going to draw a line down your face. Okay, but humans' faces, our faces are symmetrical. So we can go from the very small to the majestic, to, out in the wild, to the giant, to humans, and what about on the large scale? Okay, what am I looking at? This is the Andromeda Galaxy. You can actually see this galaxy. Well, you can see this galaxy without a telescope. Now, it won't look anything like this. It'll just look like a very faint blur. But even with binoculars, that's enough enhancement of your vision to be able to make out some of these shapes. Now, this was taken with the Hubble Space Telescope, so you'll never be able to see something this good. But it's out there nonetheless. You can go look up in the night sky and find it. And even something as massive, as a galaxy, contains aspects of symmetry. This is a disk, and we could look at it flat on and see symmetry, but even a disk viewed from the side creates an ellipse, and an ellipse has symmetry. You could imagine folding this galaxy in half, and it would look the same from one side to the other. So that to me is quite profound. That a small snowflake on planet Earth and the Andromeda Galaxy share something in common. I just think that's incredible. That should blow your mind, guys. Mind blown. So anyways, that's why I love symmetry, and you should too. Thanks for watching.